Hi, this is video number 19. In this video, we'll discuss a new topic, infinite series. Okay, so what is infinite series and what is the connection with the sequence that we have learned in the previous chapter? So in order to get the connection between those, so let we say un be the sequence, be a sequence. Of course, when I say sequence, means sequence of a real number, and we let s1 is equal to u1, s2 as u1 plus u2, s3 as u1 plus u2 plus u3, and so on up to un. Sn, let's say this is u1, u2, u3, and so on up to n. Okay, and from here we can see that if we take this s1, s2, s3, and sn as the element of a new sequence, then we have sn form a new sequence, of a real number, where the element s1 is given as u1, s2 is given as u1 plus u2, and so on. Sn is given as u1 plus u2 plus n, and so on. Okay, so the connection between those, if I denote this, the summation of each of these un, where n from 1 to infinity, so this is, we call it as a infinite series. So what is important in the infinite series is that we want to know the major thing is we want to know the convergence or divergence of the series. Okay, and this s1 u1 plus u2 u1 plus and so on, so we call this as a partial sum, and of course we can denote that as a summation of un, n from 1 to I put an I here, I from 1 to n, so we call this as a Sn, as a partial sum. Okay, now if the series of the partial sum, converge to some numbers, s, say, then we say those series un converge. Okay, so we have this thing, if un sn converge to some numbers, so which means that if we can take the series converge, means we can take a limit, the limit exists. If the limit exists, then the series converge. Yeah, so in other way, I can write this as a limit of Sn, n goes to infinity, as a summation of the infinite series n equal to 1 to infinity. This is equal to s. So which means in this case here, if the limit of the partial sum converge to a number s, then it means that our infinite series converge to that number. Okay, and if the limit, on the other hand, if the limit n goes to infinity as n goes to plus minus infinity, then we say those series diverge. Okay, so now I will give you some example on how to evaluate, how to find the value of the series. Okay. So let's look at the first example. Let's say we want to find the value of this series 1 over n plus 1. Okay, now if you look at this series, look at the terms there, 1 over n plus 1. Of course you can use a partial fraction to write this in term of a over m plus b over n plus 1, and then you can find what ab is. Then you'll get 1 over n minus 1 over n plus 1. Okay, so Sn in this case is given as, you remember that Sn is u1 u1 plus u2 plus u3 plus up to un. So if we using that our new form of writing those series, all right, so when n equal to 1, so we have 1 minus 1 over 2. That's the first term. The second term we have half minus 1 over 3, and so on, over 4, and so on, up to n 1 over n plus 1. Okay, now if you look at this minus half plus half can cancel out, 1/3 minus plus you can cancel out, and so on. You can cancel out all those things up to 1 over n. So what left is we have 1 over n plus 1. Now if you take a limit of those, limit of Sn, which means this is limit of n goes to infinity, n goes to infinity, limit of 1 minus 1 over n plus 1, that give you 1. Okay, so which means in this case we can say that the series 1 over n plus 1 converge. Alright, so this converge to 1. Okay. Or I can write just the same thing as that. Oh yeah, I can write in the n plus 1. This is a limit of 1 minus 1 over n plus 1. This is n from 1 to infinity. This is n goes to infinity. Alright, this is equal to 1. Yeah, so therefore we can say the series converge. And I'll give you another example. Let's say if I have this is first example. The second example, let's say if I want to find the summation of this 2n minus 1 2n plus 1. Again, you can write this as a, using partial fraction, you can write this as a half 1 over 2n minus 1 minus 1 over 2n plus 1. You can find this thing. Alright, if you find the partial sum of those, so what we have half, then this is when n equal to 1, so we have 1 minus 1 over 3 plus 1 over 3 minus 1 over 3, and so on. And at the end we have 2n minus 1 minus over 2n plus 1. Okay, and again similar to the previous one, so we got this is cancel out and so on up to there. Alright, so this gives you half 1 minus 1 over 2n plus 1. So therefore, if we take a limit of our partial sum, which means we take a limit of those infinity, 1 minus 1 over 2n plus 1, that give you half. Yeah, so therefore this series 1 over 2n minus 1, 2n plus 1 converge. Okay, so this is equal to half. Okay, another example. If you consider this series 2n minus 1 over 2n, so the partial sum of those, so we have this is half plus 3 over 4 plus 7 over 8 and so on. 2n minus 1 over 2n. Okay, so obviously from there 3 over 4 is definitely greater than half, right? So why I consider this? Because we want to have a general form from there, which we can find what is the we can evaluate much easier. So this definitely greater than, so this is half, plus this one greater than half, that one also greater than half, and so on, greater than half. So what we have there, this is n terms, so we have n over 2. So if we take a limit of this, if we take a limit of Sn, of course it is greater than limit of n goes to infinity, n over 2, and for that limit that goes to positive infinity. So if this limit for that goes to infinity, which means the limit also goes to infinity, so it means diverge. So in this case, so therefore this series 2n minus 1 over 2n diverge. Okay, so I hope you can got some idea. This is example number 2, number 3, right? Another example, a little bit different. So if you have this kind of series, n minus 1, okay, if you take the partial sum of those, when n equal to 1, so you got 1 minus 1 plus 1 minus 1 plus 1 and so on, up to n terms. Okay, so what we have, if n is odd, you got 1. Okay, if n is even, you got 0. So Sn is 0 and 1 when n is odd and n is even. So in this case, if you take a limit of this Sn, the limit doesn't exist. Okay, does not exist. So therefore this series n minus 1 diverge, or do not converge, or is diverge. Okay, what about this series n, where your Sn is given as 1 plus 2 plus 3 and so on, plus n. Alright, this is the arithmetic series. So arithmetic series, you know how to use the arithmetic series, right? So we have n plus 1 over 2. Right? You know how to evaluate this for the arithmetic series. We have Sn is given as n over 2 2a plus n minus 1 d, right, where your a is first term, in this case 1, d is difference between that first term, second term, third term, and so on. So we got what d is. So if you take a limit of this, take a limit of Sn, which if you take a limit of those things n plus 1 over 2, so definitely this goes to positive infinity. So therefore this series diverge. Okay, have one more example. I don't know what number is it. Number 6. Yeah, example number 6. For this series, 1 over 3 to the n. Yeah, show that I can show that this series converges to half. Okay. Now, if you consider the partial sum of that gives us 1 over 3 plus 1 over 3 squared plus 1 over 3 cubed, and so on. 1 over 3 to n. So this is the arithmetic series. So for the arithmetic series, we have a 1 over 3, 1 minus r to the n. All right, our r is 1 over 3 to the n. You can make it n or n plus 1. So we have n plus 1 or n over 1 minus 1 over 3. Yeah, 1 over 1 minus r. Our r is 1 over 3. So that gives you, this is 2 over 3. So that's, we have 2 over 3, 1 over 2, 1 minus 1 over 3, n plus 1. Yeah, if you take a limit of those, take a limit of this, half 1 minus 1 over 3 n plus 1, that gives you half. So therefore those 1 over 3 to the n converge to half. Okay, so if we consider the general form of the geometric series, general form of the geometric series. General form of the geometric series. So we have a plus ar plus ar to the n, to r squared, and so on. Ar to n minus 1 plus ar to n, and so on. And that this summation is given as, so this is summation given, this series is given as, in general form we have r to the n minus 1 for n equal to 1 to infinity. Now how to find the limit for this? How to find the partial sum for this? So if you consider the Sn of that series, this Sn is given as a plus ar plus ar squared, and so on, up to ar n minus 1. Okay, if multiply by r, I multiply this by r, so we have r Sn that equal to ar plus ar squared, yeah, multiply this by r, so we have r Sn AR squared, AR cubed, so AR cubed, and so on. Here we have ARN. We take the difference between that. Okay, take the difference between that. Sn minus Rsn. So see what happened. Sn minus Rsn. So that we have A minus 0. So A. That AR cancel out with that. AR2 cancel out with that. And so on. All those will cancel out. What left is only that. A R to the n. On the left side, I can factor out Sn, that give you 1 minus R. On the right side, I can factor out A, that give you 1 minus R to the n. So from there we have Sn is equal to A 1 minus Rn over 1 minus R. This is the general formula for the geometric series. Now from there, yeah, if R is less than 1, so what we have, Rn we converge to 0 as n goes to infinity. So which means in this case our Sn we converge to A over 1 minus R. And if R greater than 1, so we have Rn diverge as n goes to infinity. So in this case we have our Sn diverge. Right? Yeah, in the in your notes there is an exercise for you to try to find the log of 1 plus 1 over n. Now how to do this? I give you hints, the rest you do it. So you can write this log 1 plus 1 over n as log n plus 1 over n. Okay, that give you log n plus 1 minus log n. Then you can find the partial sum, then you can take a limit. Okay, so I'll stop there for this video. Bye bye. So now let me conclude a little bit what I have done in this lecture. I introduced to you what is the infinite series. All right, I introduced to you what is the finite series. I introduced to you what do we mean by partial sum, and how to get the infinite series from the given sequence. And then I introduced to you the concept of partial sum, then the limit of the partial sum. If the limit exists, if the limit of the partial sum exists, then the series converge. If the limit of the partial sum goes to infinity, which means the series diverge. Then I give you some example. So with that, I stop here. Thank you.